I hope you are fine. Hello. Yes, I hope you're fine. And this is our lecture number 10. In this lecture, we will doing about momentum. Plus, we will do one or two more things which are actually associated with the previous lesson, which I just want to clarify at that point. Right. So let's continue with that. The last lecture was when we were talking about what is the momentum, right? So, what was momentum? We talked about this in the end that momentum is a product of mass and velocity, right? And we have seen the numerical based on that as well. So, mass means kilograms and velocity means meter per second. So, this was a unit, and I already told you about that, that this particular quantity is a vector quantity and it has a proper direction. Now, first of all, there are a few things you need to understand that. Momentum, we already discussed. Now, there needs to be a system and surrounding, right? Now, remember that you're talking about two kind of system. One system is called as an open system, and the other system is called a closed system, or sometimes we call it isolated system. In an open system, energy and matter can be transferable, right? In a closed system, everything is conserved, right? So remember that when you're talking about a system, let's suppose I'm considering two cars, right? And these two cars are, one car is car A and one car is car B. They are there somewhere, and we are considering an isolated system. It means there is a nothing, no forces coming from anywhere. Whatever forces, whatever things are within the system, nothing can be coming from outside. Mostly what we call it, there will be no external force coming in. Whatever mass is there is there. So remember that when you're talking about a closed system or an isolated system in which nothing can be coming from outside, whatever is there is inside, then there is a law related to momentum, which is called as a law of conservation of momentum, which states that total momentum of a closed system will be conserved. Now, remember that we are talking about a system, not two bodies, three bodies, or four bodies. We are talking about a system in which there can be multiple bodies, there can be multiple objects in it. So, remember that when you're talking about a system, you're talking about that law of conservation of momentum. So, law of conservation of momentum is saying for a system, the momentum, total momentum of the system, which includes the momentum of this car and this car, some of these two cars are conserved, right? This is the law. And the same law can be explained in a way if, for example, these two cars are coming together, close together, and they're striking and forms a collision, then you can say that total momentum before collision must be equal to total momentum after collision, which means that whatever momentum of that system before collision must be equal to after collision. Let's suppose that car has a mass m1, and before collision, the velocity of car A is u1. Same thing, the mass of car 2 has a mass m2, and velocity before collision is u2. Total momentum before collision. What is it? M1 U1 plus M2 U2. Now, after collision, if the velocity changes to V1 for M1 and for M2 the velocity changes to V2 for M2, then you can say that total momentum after collision can be equal to M1 V1 plus M2 V2. So that is a point. Once this is a point, right? What is the next move? And what the law is saying? Law says that these two momentums will be equal, which means that M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. So remember that whenever you're talking about system, isolated system, remember that law of conservation holds, which means that total momentum before collision must be equal to total momentum after collision, or total momentum of a system will be conserved. Now, let's take an example for that. There is a question which is actually here. You can see that. They say there are 50 gram. Actually, there are 3 questions which are here. First of all, let's talk about the question relevant to the momentum. And then there is another small topic which is also associated with that. So, what is it? A diagram shows a car and a van just before the collision. And initially, that car is having a velocity which is, let's suppose, u is equal to 0 meter per second. Now, once they strike, they're saying what is the velocity of the van after the collision. So you can simply find out the momentum of the system before collision, which includes 2 cars, right? Now, what is it? That means is 990 multiplied by 10, which is equal to 9900 kilograms meter per second. That is momentum for the car, and this momentum is 0. So before collisions, the total momentum is 9900 kilograms meter per second. After collision, it will be what? The car mass will remain the same. So 990 multiplied by 2 plus, we do not know the velocity, but mass is known already, 4200 multiplied by V. So basically, now both are same. Both momentum before and after collision will be same. So this will be 18, 1 here, 9 to the 18 and 19 plus 4200 V. Now, if you solve that, you can see that 4200, let me just quickly confirm that, 9 and 90 multiplied by 2 gives you 1900 minus, it should be minus from 9900, and that would be divided by 4200. So it gives you 1.88. So velocity of that van is V is equal to 1.88 meter per second. That is how you have to solve that. You just need to compare the total momentum before collision and total momentum after collision, and you can very easily find out what will be the velocity of a van just after it collides, right? Now, next associated topic is called as impulse. Now, what exactly is meant by this impulse word? Impulse is basically, what is impulse? Impulse means force multiplied by time, and that is equal to change in moment. So basically, technically speaking, impulse equals to force time, or you can say change in momentum. Unit of impulse is newtons seconds, right? So change in momentum, either you can say it is equal to change in momentum, or you can say force into time means the same. The best example that one can give is this one. If you read it, you can find out when the rain and hail, frozen water, hits on an umbrella, they felt very different due to the impulse of the force. Now, this is very important. Why? Because when the droplet tends to splatter and roll over the umbrella, because there is only a very small change in momentum. So basically, when the water droplets are falling in, the change in momentum is very small because mass is very small and the velocity, even if it's bigger, is still the change in momentum is smaller. But when the hailstone have a large mass and tends to bounce back, because the momentum is more, so the impact will be more. So therefore, the impulse that the umbrella applies on the hailstone is greater than the impulse umbrella applies on the rain drops, because raindrops are smaller, mass is smaller. So definitely the impact on the hails are bigger as compared to uh, I mean, response on the droplets are smaller as compared to on the uh, that big one. The raindrop is definitely the smaller one, and the hailstones is bigger because they, first of all, having a greater mass, plus they just you can say they bounce back. So momentum, or sorry, change in momentum will be bigger. So this is one of the example of the impulse, right? Now let's do a question based on impulse, which will make you understand how the problems of impulse can be solved. Now, what is it? Let's check it out. If 58 grams tennis ball moving horizontally to the left, so ball is going left, right? And the mass is 58 grams. So if you divide it by 1000, 0.058 kgs, moving horizontally to the left to a speed of 30 meter per second. So speed, or you can say velocity, whatever, as we can interchangeably saying velocity and speed until they didn't they didn't give you any particular direction. But remember that, as we know that momentum is a vector quantity, so impulse is also a vector quantity, right? So it's 30 meter per second. Is struck by a tennis racket which returns the ball back to the right at 20. So speed or velocity, let's consider it as a velocity. That would be easier for you to understand. So velocity will be, initial velocity it is, and final one is, because it returns, so it will be negative, so minus 20 meter per second. Calculate the impulse of the force exerted by the racket. Now we know that impulse is equal to change in moment. So change in momentum is equal to final momentum, which is 0.058 multiplied by negative 20 minus 0.058 multiplied by 30. So when you find that value out, what is the answer for that? 0.058 multiplied by 50. And it gives you 2.9. So the value comes as 2.9 newtons seconds. Along with that, there is a minus sign. The second sign they are saying is state the direction of the impulse. Definitely, if the initial direction was on the left, the direction of the impulse will be on the right hand side, right side, right? So this is what the impulse is all about. So in this lecture, we have completed law of conservation of momentum. plus we have completed what impulses. One small topic which is actually a part of a previous lesson, but definitely I want to explain it here. What is the point of gravity, or you can say the center of gravity? Center of gravity is what? The word center of gravity means in any object, let's suppose if this is a uniform bar, the center of gravity is in the center, which means this is a point where weight of the bar existed, major weight of the bar existed, or total weight of the bar existed. So center of gravity is the point where total weight or major weight of the bar existed. For each object, the center of gravity will be different, right? For uniform object, it is mostly in the center, but for non-uniform object, there are different center of gravities, right? So this is what the point which we have missed. And in the next lecture, we will continue further. In that, we will continue with the work power energy in the next lecture. I hope you understand that. So hope to see you in the next lecture. So it's bye from my side. See you.